Okay, let's talk about reactions of aromatics and alcohols all here at the same time. Knock two out alcohols. So, as we've learned, aromatics contain a benzene ring. This is how we draw a benzene ring. It's a resonance structure. Because of its nice resonance structure, it does not like to add things in. It only likes to substitute. So here, I'm gonna halogenate. Halogenation means add in a halogen. I'm going to add in a Cl, a single Cl. So one H is coming out, one Cl is going in. This is my catalyst here. Nitration, I'm going to react a benzene ring with HNO3, which is an acid. I need another acid there. I'm going to replace an H with an NO2 group. I can actually stick a hydrocarbon chain onto this benzene by using this as a catalyst. Cl is on here. Bang, it sticks on, and I guess I would get some other byproduct, but I don't care about it. I'm only interested in the major product. I do want to point out here that if I was trying to use Br2, I would use FeBr3 as my catalyst. If I wanted to add on F2 with FeF3 and so on down the line, those would be the corresponding catalysts for each reaction. Alcohols. So let's talk about alcohols. I can substitute alcohols, means the OH is coming out and something's going in. Here I can try to substitute in a Br, so here I've got my 4 carbons, they haven't changed. The OH is coming out, the Br is coming in, yes. And I would be left also with H2O, because this would join up with this H, and I would get H2O. Condensation, I can try to suck a water molecule out of this. I've got cyclohexane. This is not benzene because it has not been drawn with the circle in the middle. And this H2SO4, sulfuric acid, is actually an excellent dehydrator. So what would I get here? I would get, there's 2 H's here and here also. So what's going to happen is that's coming out, and one of those is coming out, and then I'm going to make these carbons happy, I'm going to have to make a double bond. So I would get a double bond here, and I would get water. Yes. Oxidation, remember the definition of oxidation is more bonds to O or less to H. Right now, this guy is making 1 bond to O. More would be 2. So I might get, here's my carbon chain. So that's a possibility, yes. Another possibility would be, this is a ketone. Another possibility would be to have my 4 carbon chain, and instead of getting 2 bonds with a double bond O, I could get another OH group going on. Yes. This is a diol. If I try to oxidize an aldehyde, if I try to oxidize a primary alcohol, I would get an aldehyde, so it would be 3 carbons long. Right now, this guy's making 1 bond to O. More would be 2. If I oxidized this, I could get yes, and if I continue to oxidize this, I could get this to turn into a carboxylic acid. Yes. If I decide to react two alcohols together, and they don't have to be the same one, and I'm trying to get that across by using R1 and R2, you could get this OH to come off and this H to come off and make water, and then what's left over would stick together, and so you would get R1 bonded to an O bonded to an R2, which is an ether. Yes. And finally, alcohols are used in this reaction called esterification, where I'm making esters. And here I get the OH and I get an H coming together to make water. I definitely need an acid as my catalyst here. And then I get the leftover stuff sticking together. I get an R2 bonded to a C, double bonded to an O, bonded to an O. That's all I've done is redrawn everything except the H. And now the R1 comes on. And this is an ester, or yes, an ester. Okay. So these are just some of the reactions that aromatics and alcohols undergo, and yes, you do need to know some of these catalysts when we have a test. And I did draw here, these are some things that act as oxidizers. Potassium chromate, potassium permanganate are excellent oxidizers. They could be something that's here, depending again on what you want to make